Hello students, welcome to the third session of our third module in RIC. And students, we have studied different types of multiple stages in stages of compression in vapor compression refrigeration system, right? So students, we have already discussed it 3 to 4 times. I think mainly 3 types. So first one was two-stage two-stage compression, two-stage compression with liquid intercooler, right? And second one was two-stage compression, two-stage compression with water subcooler and liquid subcooler. Water water intercooler, right? Water intercooler and liquid subcooler. And third one was important, two-stage compression with water intercooler, liquid subcooler, and with water intercooler, liquid subcooler, and what was that? Flash gas removal, flash chamber, right? So we have written it as liquid flash chamber. So in flash chamber, what was happening? Flash gas was removed, so that the refrigerant coming into the evaporator will be completely liquid, saturated liquid form. It will be in saturated liquid form. So FC means flash chamber, okay? Liquid, LS is liquid subcooler, WA is water intercooler. So these three types of multiple stages of compression system we have already studied. And students, today we are going to learn a fourth type called is two-stage compression system, two-stage compression with water intercooler, okay, water intercooler, and okay, liquid subcooler, and instead of flash chamber where flash gas is removed, I am using flash intercooler. So slight difference is there between flash chamber and flash intercooler, okay? So flash chamber and flash intercooler. So you can see here. So instead of flash chamber, which was used for flash gas removal only in the previous case, here I am using flash chamber as a flash intercooler, okay? So this is a flash intercooler. Intercooler means there is two streams. There is an exchange of heat between two different streams. So do you remember how actually was flash chamber where flash gas is removed? I will show you that pic also, then you will understand the difference, okay? So this was the third type of multiple compression system we have studied. So here the flash chamber was used as liquid flash chamber where just one stream is going out of two stream is going out of the flash chamber, only one stream is incoming. So this is the only incoming stream. Two stream were going outside or from exiting from that particular flash chamber. So the difference is that, so what was the difference? Difference is that the flash in the flash chamber, the refrigerant is separated. The refrigerant, which was a mixture of vapor and liquid, was separated, and liquid goes this direction, vapor goes this direction, okay? So that was the case. But here, what is the case? But here what is the case? Some the liquid, sorry, the high pressure, high temperature refrigerant coming from low pressure compressor enters the flash chamber. Okay, enters the flash chamber, and the in from the flash chamber some of the the refrigerant will get separated, right? The liquid and vapor, the mixture of the actually the refrigerant will be a mixture of liquid and vapor, and this vapor goes upward and liquid goes to the evaporator. So this separation also takes place. Okay, so actually there will be two incoming streams and two okay, outgoing streams. Okay, that is the difference between a flash intercooler and a simple flash chamber. So simple flash chamber only three streams. One is incoming, two is outgoing. Here four streams. Four streams means two incoming and two outgoing. And a very important difference is that in the third type you can see that I have here a water intercooler is used, and by using a water intercooler after the compression, first stage compression, and when it is passed through the water intercooler it gets cooled to the position the state 4, right? But 4 is still outside the saturated vapor line, right? Outside the saturated vapor line, and it means that it is still in superheated state. So I have already told you that whenever the position state reaches, or when the state of the refrigerant is on that saturated vapor line, the work of the compressor will get reduced, because the lines close to that vapor dome will yield you lesser work. Okay, whenever the state of the refrigerant moves away from that vapor dome, the work increases. Okay, so it will be favorable to us in decreasing the compressor work if you cool this, if the water intercooler cools the refrigerant such that it reaches the saturated vapor line. Okay, saturated vapor line. But here by using water intercooler you cannot reach that state. Okay, so water and a cooler won't the temperature will never get reduced to the saturated vapor line before before admitting it into the high pressure compressor. So before admitting it into the high pressure compressor, the water intercooler or the intercooler should reduce the temperature to the saturated vapor line. Okay, so here in this particular type it is not possible. Okay, but here, since along with the water intercooler I am using the flash intercooler, you can see that. So this is the pH diagram for the fourth type. You can see that the point 4 reaches here. So point 4 reaches the saturated vapor line. So very important, it reaches the saturated vapor line, so that we can reduce this work. So whenever the isentropic line is closer to the saturated vapor line, so this is an isentropic line. 4 to 5 is an isentropic process. Whenever the isentropic line is close to the saturated vapor line, this H5 minus H4 will be a smaller value. So that what does it mean? It means that the work required for the compressing the vapor, in the high pressure compressor is little bit lower. Okay, so that is the idea. So here you can see that the same. So I will explain you the working of this particular type. So two-stage compression with the water intercooler, liquid subcooler. So this can be deleted again. So hope you have understood the difference between two-stage compression with the water intercooler, liquid subcooler, and liquid flash chamber with two-stage compression with the water intercooler, liquid subcooler, and flash intercooler. Okay. So let me delete this particular. Okay, this particular can be deleted. I think. Okay. Now I will explain the working of this particular type. Okay, so what is the first it is inlet of the low pressure compressor. So at the inlet of the compressor means it is in the saturated vapor form. So saturated vapor form, it is isentropically compressed to the state 2, right? So it reaches 2. Okay, from 2 to 3, what is happening? 2 to 3, 2 to 3, it is cooled in water intercooler. So 2 to 3 means 3 will be in between. 3 will be in between the second point 2 and point 4. Okay. So it has by cooling through water intercooler, it doesn't mean that it is completely cooled. Its temperature is completely reduced up to the saturated vapor line. It hasn't reached the saturated vapor line yet. To reach saturated vapor line, even more cooling is required. So how will you do that? So I am using a flash intercooler here. A flash intercooler is used so that after entering to flash intercooler, it will exit from that flash intercooler at the state 4. At the state 4 means it is completely in the saturated vapor form. So it reach saturated vapor form. Okay. So after flash intercooling, what happens? From 4 to 5, it will 4 means it enters the high pressure compressor and it gets compressed to 5. So it reaches 5. So this pressure is condenser pressure. At condenser pressure, it gets condensed to 6. Okay, it gets condensed to 6. And after the condensation process, it will enter the liquid subcooler means it 6 the position 6 state 6 will be on saturated liquid line, and for undercooling or subcooling, so that we can improve the, so if subcooling was not done, then only this much amount of refrigeration will be obtained. So in order to increase the refrigerating effect, we will subcool it to 7. Okay, so 7 means H7. So the refreshing effect will be increased this much. Okay. So after subcooling, what will happen? It will pass to an expansion valve, first expansion valve. So this is expansion valve, and in expansion valve, what will happen? Its temperature and pressure gets reduced to 8. 8 means the intermediate pressure. The pressure corresponding to the outlet of the low pressure compressor. So from 8, what will happen? It enters the flash chamber. So in flash chamber, it will exchange. So here in flash chamber, what will happen? In flash chamber, what will happen? It will get separated. The refrigerant will get separated. The separated into saturated. Some part will become saturated liquid, and some part will become saturated vapor. So saturated vapor goes this direction. Saturated liquid goes this direction. So saturated liquid will have the state 9, and it will move to the second expansion valve. So in second expansion valve, its pressure get reduced to the evaporator pressure P10. Okay, and the saturated vapor will mix with this incoming. Will mix with 3 to form 4. Okay, so it will mix with 3. So 8 will mix with 3 to form 4. Okay, I will show you once more. So this the state 8 will mix with the state 3 to form state 4. The mixing takes place and state 4 will be saturated vapor. Saturated vapor. So what is actually what is actually taking place here? So H3 will have an enthalpy of the refrigerant at state 3 will have an enthalpy of H3. So H3 will be a higher value, right? It will be a higher value. H8 is a condense. It is coming from condenser, right? So it means its temperature is low, and it is a low pressure, low temperature refrigerant. At H3, at position 3, it is a high pressure, high temperature vapor. So when both are mixed, actually the stream here will absorb heat from the stream at 3, so that 3 will get cooled to the saturated vapor line. Okay, so that is what happening here. And from 10, what will happen? 10, it will enter to the evaporator and forms and reaches state 1. So that is the process taking place here. So whenever there is a flash chamber, you have to remember that there will be a separation. There will be a separation of refrigerant. The refrigerant mixture will get separated to in vapor and liquid, saturated vapor and saturated liquid. So whenever there is a flash chamber, whether it is intercooler, whether it acts as intercooler, or whether it acts just for flash gas removal, you have to understand that at 8 it will separate to two different stream, separate to saturated vapor and saturated liquid. So from 8 you will get saturated liquid and saturated vapor. Okay, so when this acts as intercooler means it will be on this saturated vapor line. When it acts as just flash gas removal, it will be outside the point 4 will be outside the saturated vapor line. So that is the important point to remember, the difference between flash chamber flash chamber. So flash chamber with for flash gas removal only. For flash gas removal only means, so this will be the graph, and for flash, sorry, if this is pH diagram, you can see that one for flash gas removal 1 to 2, 1 to 2, 1 2, 2 to 3, 3 to 4. The 4 will be outside. Sorry. So pH diagram in case of flash chamber, which is used for flash gas removal only, means 1 to 2 and 2 to 3, and 3 will be intermediate of 4 and 2, and 4 will be outside the vapor dome, or outside the saturated vapor line. But in case of flash chamber, uh, flash chamber used as a flash intercooler, what will be difference? The point 4 will be on that particular line itself. 4 will be on the saturated vapor line itself. So 2 will be here, 1 will be here. So for the based on the position of 4, in case of flash intercooler, the state 4 will be on that saturated vapor line itself. In case of flash chamber used for flash gas removal only, 4 will be outside the line. That's the difference. Very important. You should be very clear about the concepts. Okay, so students, if m1 is the mass of refrigerant passing through the low pressure. M1 dot is mass passing through low pressure compressor. M2 dot is mass passing through high pressure compressor. So both in kilogram per minute. Okay, both in kilogram per minute. Then how can you? So if Q is the uh, what Q is the tonnage of refrigeration capacity of that particular. So you can write M1 is nothing but 210 Q. So since M1 dot is in kilogram per minute, you have to make it kilojoule per tonnage. Tonnage of refrigeration can be converted into kilojoule per minute if you multiply it with the 210 into H1 minus. So what will be the refrigeration here will be 1 and 10. 1 to 1 and so H1 minus H10. Okay, H1 minus H10 will give M1 dot into H1 minus H10 will give it 210 into Q. Okay, so thus you can obtain M1 dot. So because through evaporator actually through evaporator only M1 dot is passing. Okay, M1 dot is passing through this particular circuit, and through this circuit M2 dot is passing. M2 dot is getting circulated. Okay, now if you need to if you need to find M2 dot, you have to take the thermal equilibrium of the flash intercooler. So flash intercooler is this one. So some M1 dot is entering here, and outgoing from here, and here M1 dot. So this is the flash intercooler. Okay, actually flash intercooler there will be a floating valve also. So you have already learned the function of the floating valve. It is connected to the expansion valve. So whenever the level of liquid here is reduced, the floating valve gets activated and more expansion will be done. So that is the working of floating valve. So don't worry about that all. Now the stream is actually stream is like this: two incoming streams and two outgoing streams. Okay, and how to find the, so what are the enthalpies associated with all these streams? So enthalpies associated here will be, this will be H3, this will be H4, this will be H8, and this will be H9, right? So here, so here H, so here it will be H3, right? Here it will be H4, this will be H9, and this will be H8, right? So I can write that heat taken by the intercooler is equal to heat given by the flash intercooler. Heat in is equal to heat out. That is the equilibrium condition. So heat in is, incoming stream is 1 M1 dot H3 plus M2 dot H8 is equal to outgoing M2 dot H4 and M1 dot H9. M2 dot H4 plus M1 dot H9. So this is the equilibrium, thermal equilibrium condition for flash intercooler. And from this you can write M2 dot is equal to M1 dot H3 minus H9 by H4 minus H8, right? So H3 can be, so H3 is this one, H9 is HF9, okay, and H8 will be H7 itself. So you can do the calculation, no problem. If you know this, so H3 means H3 itself, H9 will be HF9, and H4 will be HF4 itself, and H8 is nothing but H7, because 7 to 8 is an isenthalpic process. So this is a method to get the flow rate in the second circuit, in the high pressure circuit. Okay. And if you need to find the refrigeration effect, you just need to write M1 dot into H1 minus H10. So H10 will be HF9 itself. HF9 is 10, 9 to 10 will be an isenthalpic process. Okay, so you get the, so I already written that. Okay, refracting effect is obtained to get the compression work W1 plus W2 or LP and HP. High pressure, low pressure compressor and high pressure compressor. Both work should be added, and that will be equal to M1 dot into H2 minus H1 plus second one is M2 dot into H5 minus H4. Okay, so that will be the total work, or total work per total power. So not work, power, because m1 dot is this is a mass flow rate, you know? So it will be in kilojoule per minute. Actually, since m1 dot is in kilojoule per minute, to get in kilowatts, if you divide by 60, you will get power in kilowatts. Okay, power in kilowatts if you divide it by 60. So those calculations and all, you are very you will be knowing those calculations. You are very familiar with those calculations, so no much worries about those. So COP can be obtained by refracting effect by total work or power. Okay, so that's all about the two-stage compression with the flash intercooler. Now students, we have already studied 4 types of different compression systems. So all these 4 types were two-stage compression. So all these four different types can also have three-stage compression. If you add another compressor intermediate to this low pressure compressor and high pressure compressor, it will become a three-stage compressor. So there is no much complexity, there is no much new novel ideas about novel concepts about this three-stage compressor. You just add another compressor in between these two compressors. So accordingly there will be a change in pH diagram. So one more line comes in between these one more line of intermediate pressure comes in between those pressure lines. So I will give this as an assignment to you to write the 4 types of three-stage compressor. Write about three-stage compressor. So if you complete that also, then the topic related to multiple stage compression will be completed. So now I will move to multiple evaporators, the systems that uses multiple evaporators. Okay. So students, now we will move to multiple evaporator system. Okay, multiple evaporator system. So we are done with the multiple compressor system. Now we will move to multiple evaporator system. So this is the first type of multiple evaporator system. Multiple evaporators at the same temperature with a single compressor and expansion valve. Okay, so single compressor and expansion valve. So you can see that there are uh, three evaporators. You can see 3 evaporators and 1 compressor, 1 condenser and 1 expansion valve. Okay, so all the 3 evaporators are connected parallelly. So it is used when the number of loads such as food products are kept in different compartments are to be maintained at the same temperature. So very important, all these 3 evaporators will maintain same temperature and it will be in the same evaporator pressure. You can see here. So all the 3 evaporators together, so total refracting effect will be the sum of refracting effect of E1 plus sum of refracting effect of E2 plus refracting effect of E3. So that will be the condition. Okay, here you can see that the one after compression at the inlet of the compressor, the vapor will the refrigerant in the vapor form will get inducted or sucked into the compressor. After compression, it will undergo isentropic compression to reach 2 to 3. 2 to 3 is condensation, 3 to 4 is expansion, and after expansion it will the temperature will be T4, pressure will be P4 is equal to PE. It is expanded to the evaporator pressure. Okay, so this evaporator pressure at this evaporator pressure, the refrigerant will be split into three. Okay, you can see that each to here, and to here, and it will be split into three, and these three different streams absorb heat from the space to be refrigerated and reaches the same value and reaches the same temperature T1 and gets joined or mixed together again, so that it enters the compressor. So that is the first type of multiple evaporator system. They are so very important at same temperature and single compressor. So same temperature means inlet temperature and outlet temperature of all the three evaporators will be the same. Okay. So actually this together acts as a single evaporator. So that single evaporator is E. Okay, so here it acts as only single evaporator E. So you can see that if Q1, Q2 and Q3 are the loads on each evaporator respectively, in ton of these are in tonnage of refrigeration. Okay, so mass, what will be the mass of refrigerant circulated through EP1 is the evaporator 1. Mass circulator M1 dot will be how much in kilogram per minute? 210 into Q1 by what will be the the enthalpy difference is nothing but 1 and 4, H1 and H4, right? We can write it as H1 minus H4. So similarly, M2 dot will be 210 into Q2 by H1 minus this H1 minus H4 is same for all the three different evaporators, to 210 Q2 by H1 minus H4 again. Okay. So the total mass M dot will be M1 dot plus M2 dot plus M3 dot. Okay. So you can see here. The mass flowing through this circuit will be M dot, and this circuit will be M3 dot, M2 dot, M1 dot. So okay, M2 dot, M1 dot. So all these three different streams get mixed together here to form M dot, and from here M dot will be split into 3 again based on the load of the evaporator. So based on the load only, so based on the load Q1, Q2, Q3, you will get M1, M2, M3. But the inlet and outlet temperature of the evaporators will be same only, because they are maintained at the same temperature T4 and T1. Okay. So how to find the work on? So work of the compressor will be, you can see that work is 1 to 2, right? So 1 to 2. So what is the mass flowing through compressor? M dot. So M dot into H2 minus H1 will be work of the compressor. So m dot is nothing but m1 dot plus m2 dot plus m3 dot. Okay. Now COP will be uh, refrigerating effect by work. So what will be the refrigerating effect? Refrigerating effect will be nothing but m dot into actually m1 dot into h1 minus h4 plus m2 dot into h1 minus h4 plus m3 dot into h1 minus h4. Since there are three different evaporators, the load on each different evaporator will be added together to get net refrigerating effect. Since h1 minus h4 is common, you can write refrigerating effect is equal to m1 dot plus m2 dot plus m3 dot into h1 minus h4, or this will be m dot itself, m dot into h1 minus h4. Okay. So that's the case with multiple evaporators with single compressor, single condenser, single expansion valve maintained at same temperature. Okay. Now we'll move to another type of multiple evaporation system. Okay. So students, this is the second type of multiple evaporator system. You can see here multiple evaporators at a different temperature, very important, with the individual compressor for each different evaporator and individual expansion valve. So students, we have three different evaporators, so evaporator 1, evaporator 2, evaporator 3. So each different evaporator has got its own individual compressor 1, 2, 3 and its own individual expansion valve 1, 2, 3, and they are maintained at different temperatures. That's the important point. So here you can see that instead of one single line, so in the previous case EP1, EP2 and EP3 were on so EP1, EP2 and EP3 were on one single line only. So but here you can see that they are at different, they are having different lines, means they are having different pressures and different temperatures. Okay, the temperature of EP1 will be corresponding to this line. Okay, and second evaporator this, third evaporator this. Okay, so how is the working of this particular type? So you can see that the refrigerant, the saturated liquid coming from condenser gets splitted into three. So first here passing through here M1, this line M1, and this line M2 and this line M3. Okay, so it is from so it will be split into three, right? So after expansion, so you can see here from 7 some part of 7 will enter to the E1 expansion valve. So from 8 so the at 7 the saturated liquid line, the saturated liquid coming from the condenser will expand in expansion valve 1 to the point 10, and some part will get expanded from 7 to 9, and so in expansion valve 2, and some part will expand from 7 to 8 in expansion valve 3. So from 10, the state at 10, the amount of refrigerant passing through the expansion valve 1 will pass through the evaporator 1. So this much amount of refrigeration takes place in EP1, and this much amount of refrigeration takes place in EP2, evaporator 2, and this much amount of refrigeration takes place in EP3. Okay, EP3. And after getting refrigerated, in evaporator, so 1, so it will reach 1, right, in here 1, and 1 will undergo a isentropic compression to condenser pressure. So this is the condenser pressure P7. So P7 to, so P7 will be equal to P2, and so you must note that here compressor 2 will compress it to 4, compressor 3 will compress it to 6. Okay, so P2, P4, P6, all this pressure will be equal to P7. So this is a one particular line. Okay, so you have to note that the outlet temperature, the output of the output of all the compressor will be same pressure line. So you can see that they will have all the compressor compresses the vapor coming from evaporator to same pressure, same condenser pressure. So condenser pressure P7 will be equal to P2, P4 and P6, right? So while drawing the schematic of this particular system, you have to note that the outlet line is same. All the three compressor is having same common outlet line. So P2, P4 and P6 and P7, all of them are having same outlet line, but inlet line is different, because at inlet, here inlet pressure is 1, A1, here inlet pressure is 3, here inlet pressure is 5. So that is the difference. So all the three different compressors are compressing to the same pressure, same condenser pressure. So that is the working of this particular system. Okay, now we can calculate the refracting effect, mass flowing through three different circuits, and work in each compressor and COP. Okay, so mass flow M1 dot is the mass flowing through EP1, right? So EP1 will be, if the Q1 is the load on EP1, the 210 by Q1 will be, so what is enthalpy difference through, so this is the enthalpy difference, H1 minus H10, right? So if Q2 is the load on EP2, then M2 will be 210 Q2 by, what will be the load, H3 minus H9, right? H3 minus H9. Similarly, M3 dot will be 210 Q3 by H5 minus H8, right? H5 minus H8. Okay, this is how we find the mass flow rate in all three different circuits. So here it will get joined by all the three will be joined here. So here M dot will be M1 dot plus M2 dot plus M3 dot. Here splitting takes place. So from M dot, some M3 dot goes here. So M dot minus M3 will be flowing through here, and M2 dot goes through here, and finally M1 dot flows through here. Okay, so very important. Now we have to find the work in, so work or power in first compressor power will be 1 to 2, right? So M1 dot is flowing through first compressor, so H2 minus H1. So in order to get in kilowatts, divided by 60, this much kilowatts. Okay, so P2 will be M2 dot into, what will be it, H4 minus H3. H4 minus H3 by 60 kilowatts, and similarly P3 will be M3 dot into H6 minus H5, H6 minus H5 divided by 60, and total power P total will be P1 plus P2 plus P3. Okay, so in order to get COP, you have to get total refracting effect by total power. So what is total refracting effect? Will be Q1 plus Q2 plus Q3, right? So into 210. into 210. If you do it 210, you can convert it into kilojoule per minute. Or if you divide, okay, you make it in kilowatts. If you put 3.5, you will get in kilowatts. Okay. So this is how you find COP and refreshing effect and work in case of the multiple evaporator system at different temperature with the individual compressors. Okay. So with this I will conclude this session. So there are lot of combinations in case of multiple evaporator system. There are some more than almost more I think more than 6 or 7 combinations of multiple evaporator systems are there, but I won't be taking classes on all those different types. I've already taken some 2 types and I take 2 more types, and rest and the other types remaining should be learned by yourself. Then only you can understand the concepts on your own. The concepts will be cemented, or foundation will be cemented strongly in your mind. Okay. And you have to take some efforts on your own. Okay, otherwise we won't be able to complete the portions also. So kindly cooperate with me. So for the time being I am stopping this session. Thank you.